be analyzing the motion of the projectile from a Nerf gun.
So pretty much we're gonna test how far it's gonna be shot, and we looked on an official website about the Scout IX-3, which is a gun that we're gonna use to determine pretty much how far the bullet is gonna be shot. And this is a Nerf brand gun. A Nerf brand gun. We're going to be using Whistler darts, as you can see on here. And as it says on the chart over here, at a 0-degree angle, as it's being shot, it's going to be about 30 feet or 9 meters. As I mentioned earlier, these are our Whistler darts, which are our projectile, and they will be starting at their peak because the gun is going to be pointed horizontal to the ground, so it won't be pointing straight up or down. It'll be.
This here is a sketch of how the projectile should look in its motion. As you could see, the vectors that are blue, which show the y velocity, are getting increasingly bigger and in the downward direction because of gravity, of course. And the red vectors, which show x velocity, are staying about the same length. And I only say about because of the way I drew it. In reality, these x velocity vectors will stay the exact same length. One thing to keep in mind is that the projectile will be starting at its peak. Alright, so we're out here on the road. Louis is at the starting position. Fabricator is going to mark the final position. We're going to measure the distance between. Now, we chose Louis to fire the gun because Louis is about the height of an average adult, which is probably what Nerf measures when they're seeing how far you could shoot it. So we're going to give this a try. Ready? 3, 2, 1, shoot. Fabricator has marked it, and we are good to go.
So we did the experiment several times, and right now Anthony's behind us measuring how far the distance of each bullet went, and they were practically the same distance, so he's just going to measure one of the bullets' distances. The x-axis is positive because it is moving in the forward horizontal direction. It is also constant when there is no gravity acting up.
There's no acceleration in the x direction, and the acceleration in the y direction is always negative 9.8 meters per second squared because of gravity.
Peak, the y position is at its highest value.
Y velocity is 0.
X position is 0 meters.
On the way down, the y position is moving negative at an increasing rate.
Y velocity is negative and decreasing.
X position is moving positive at a constant rate.
At the bottom, the y position is 0.
Velocity is at its lowest value.
Position is 6.756 meters in the positive direction.
Air resistance is a variable we do not account for, but can affect the projectile because the wind in the air can change direction or cause the projectile to speed up or slow down. Also, the surface area of the dart and shape of it causes it to glide a certain way. Angle is another source of error because the angle can make the dart go further or shorter. As we mentioned before, 45 degrees is the optimal range angle. Initial velocity is the final variable, as it will not be perfect with each shot, and more velocity will cause the dart to generally travel further.
What was the distance recorded by our measuring tape?
Well, Mr. Hine, it was 6.756 meters, which is 2 meters shy of what Nerf said.
So Louis, what does that make Nerf?
That makes Nerf a liar.
As a group, collectively, we were pretty shocked by these results because we thought it'd be much closer. Not 33% error, which is a lot, to be honest. So we did some calculations, and we found out that if it were to be fired flat and go 9 meters, that the adult would have to be 3.89 meters tall, which is approximately 12 feet, and nobody's 12 feet, so that's obviously a lot of bogus. And we also calculated that if it were fired at a 45-degree angle, which is the optimal range angle, it would go well over 9 meters. It would sound much better if they were able to say it could shoot 14 meters rather than 9 meters.
Nerf or nothing, but
It's Nerf or nothing!
we say
Don't trust Nerf for nothing!
Look at